Okay, folks, we're going to go ahead and do day 2 of identities. So I'm going to go over again the identities. We're going to add a couple of them today, and mostly it's practice. So again, everyone should have this card stock. Please keep it. It's going to be important to use as we move forward. We have our reciprocal identities. Again, these are some that you should be familiar with, specifically that cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. But you have them as a reference. These are going to be things we're going to use. The quotients, the tangent is sine over cosine, and the cotangent is cosine over sine. That's important to remember. And then the Pythagorean ones, these were new ones that I gave you from last time. The first one is that if you square the sine and you square the cosine of the same angle, that's always going to add up to 1. And then these next two identities are basically just this first form manipulated. So in other words, getting the sine by itself, I subtract cosine from both sides. So again, if you think about it, if I had sine squared x plus cosine squared x equals 1, and I want to get the sine squared by itself, I'm going to move the cosine squared. So I'm going to do the opposite. So minus cosine squared x. Those go ahead and those eliminate, go to 0. You're left with sine squared x equals 1 minus cosine squared x. So that's where that first one comes from. That 1 minus cosine squared x equals sine x, sine squared x. That's what the following two in each one are. So the next one has to do with tangent and secant. So 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. So that's what we talked about last time. What I want you to do is I want you to have these handy as we do the problems, because that's going to help you out a bunch. What I'm going to add today is this idea of odd and even identities. And what it means is if I have a negative sign in here with whatever variable I have, like the sign of negative sign, I can bring the negative sign up front. So negative sign of negative theta equals negative sine theta. The negative sign comes out front. Since cosecant has everything to do with sine, it follows through with cosecant. Cosine, the negative goes away. So if I have a cosine of a negative theta, it's the same as cosine of positive theta. So, and then secant goes with cosine. So these are ones we're going to use again today. And then there's some notes down here if you want to take a look at, just to remind yourself. If tangent x is sine over cosine, tangent squared is sine squared over cosine squared. If secant squared is 1 over cosine, secant squared is 1 over cosine squared. And the big thing is with the Pythagoreans, it does not mean that 1 minus cosine x equals sine x. I can't just take the square of each side. So here's the deal for today. Again, what I want you to do is I want you to look at these problems. So I'm going to kind of jump around. I'm not going to do all of them. But like, so for example, secant cosine, since I don't see a squared here, I'm not going to use a Pythagorean. I'm probably going to end up using a reciprocal or a quotient. So what I want to do is I want to look and see, what does secant x equal? Oh, secant x equals 1 minus cosine x. So what I can do is I can rewrite secant x as 1 over cosine x. And now I have 1 over cosine x times cosine x. Those two eliminate. You're left with that 1. Okay, so that's how you're going to kind of approach one like that. Tangent squared minus secant squared. So again, this has got a square, so I'm going to go down here and I'm going to look and see. Tangent squared, secant squared. Oh, well, it does give me secant squared minus tangent squared. It's not the same. So how would you change this? The way you would change this is I want to get this so that the secant is positive and the tangent is negative. What I can actually do here is I can factor out a -1. And when I take out a -1, that's going to become negative tangent squared x plus secant squared x. I changed the signs. And if I really want to, I can rewrite that as secant squared x minus tangent squared x. So now what I've done is I've manipulated this thing that doesn't look familiar into something that does look familiar. I can now replace this secant squared tangent squared with a 1. -1 times 1 gives me -1. That equals -1. So I'm going to kind of keep bouncing around. So now, sine of a negative, cosine of a negative. This is the new one. Sine of a negative says I can bring the negative sign up front. Cosine of a negative says I'm going to make it a positive. So what this tells me is that this top guy is going to be negative sine x. The bottom guy is going to be positive cosine x. Now I want to simplify it even further. I got a sine, I got over a cosine, I got a sine, I got over a cosine. I can rewrite this piece, not the negative sign, I can rewrite this piece as tangent x and then bring the negative sign down. And again, what you're going to do is you're going to look at things like this and say, oh, I see a square. Square tells me that I'm going to go look at the Pythagorean. 1 minus cosine squared. 1 minus cosine squared. That's sine squared x. So what it means is I can rewrite this top guy as sine squared x. And down below, I've got sine x. And the same rules apply that if you had this. If I had x squared divided by x, you would tell me it's x because I just subtract the exponents. I can do the same thing here. Sine squared x divided by sine x is going to equal sine x. I'm skipping around because some of these are just kind of repetitive to what we've done before. So again, this one's got a sine and a secant. So that's one where I'd probably go to the reciprocals and look and see what I could do. Same idea with cotangent and secant. This one would probably tell me to go to a Pythagorean. This one would tell me to go to a Pythagorean. And I work my way through. So now let's go ahead and bounce down to these ones. So this one says sine of negative x over cosine x. Again, sine of a negative, I can bring the negative out front. This becomes negative sine x over cosine x. And much like this one up here, this is negative tangent of x. And let's see, what else do I have? I think of all the others, that's pretty much the ones that you're going to deal with. All the other ones have something to do with finding a reciprocal or a quotient or a Pythagorean. And I put the answer key up on Schoology. So what we're going to do is we're going to work on this in class today and finish this up. This is kind of going to be our turn-in, the thing we're going to turn in. Want to see you again on Friday. We're going to get into ones where we're going to do this to prove things. So there's going to be an equal sign there. And what we're going to do is use those identities to verify whether things are actually in fact true. So please use the reflection. Again, it's optional now, but use the reflection if you have any concerns, any feedback you want to give to me. Otherwise, I will see you next class.